Welcome to Study Loop.
Okay, hello. So today we are going to be talking about this reaction, which is beryllium chloride plus we are reacting in a chloride ion or multiple, we'll see depending on how we balance it, from molten NaCl. So we're taking the chloride ion from molten NaCl and we're basically forming this ion, which will give beryllium a complete octet. And just to make sure, so we have two chlorines here, we have 4 in the final product, so we need to put 2 of the ions from the NaCl. And we want to do this, we want to depict this reaction with Lewis structures. So let's start with the beryllium chloride. And we will, as always, start by drawing single bonds between beryllium and the chloride. And then we will fill in the rest with lone pair electrons on the chlorine. So we have a total of 2 plus 7 times 2 equals, we have 16 total valence electrons. And we have 4 taken care of here, so the rest are going to go in 6 lone pair electrons on each chlorine. Okay, we've completed our 16 electrons, we're all set, but the problem is beryllium does not have an octet, and that's why we're reacting in these 2 chloride ions in order to give it the full octet. So Cl minus will have 8 electrons because Cl normally has 7 plus the 1 from the negative charge, so that gives us that. And we have 2 of those, so we'll draw 2 like this. And then we can draw our final product. And you may notice that it's going to be as simple as just adding in the 2 additional chlorines on the top and on the bottom. So we'll put 1 chlorine here, 1 chlorine here. It's a little close, but you get the idea. All right, and that gives us our 4 chlorines, and we can fill in the lone pairs as before on the 2 that were already there. And on the 2 we added, we can just realize that the bottom 2 electrons of this chlorine and the top 2 of this, kind of, if you're thinking of this going here and this going here, are basically going to become the single bonds. And also, I want to make sure that I don't forget to put a bracket with the 2 minus to show that we have an ion. And, oh, I forgot these here and these here. And then we want to make sure we have the right number of valence electrons. So in total, we have 32 here because you can just count the 2 in the single bond as 2 plus the 6 on each of the chlorines. That gives us, so 6 here, 6, right? 6 valence electrons in each chlorine plus the 2 in the single bonds, right? That is going to give us a total of 32. So 32 is what we have, and if we count, we have 2 plus 7 times 4 is also 32. So that matches, and we're all set, and we've drawn the ion correctly. So yeah, you just want to make sure that you count everything, both the lone pair electrons and the bonds, and make sure it matches what you should have. All right, I hope this made sense.